Is I'm audible? If it is also visible, just give me confirmation. Is I'm audible? Is anyone give me confirmation I'm audible? Is I'm audible? Please give me confirmation. If it is also visible, is anyone give me confirmation? Is anyone give me confirmation I'm audible? Yes. Anyone give me confirmation I'm audible?
Yes, sir.
Okay. After the sixth one is combining grooves and fillets. For the combining grooves and fillets, see the sketch here. Here the grooves also there. The shoulder will be also there. Sharp corners, right? And also here in the sharp corners and grooves also be there. Then we'll go for combined it, right? When you go for combined it, now you get like this: the grooves and sharp corner. The last one is using undercuts. What is undercuts here? Instead of using a fillet, we'll go for the undercut, the shaft that will reduce the stress concentration. That will reduce the stress concentration. These are the 7 methods are there to minimize or to reduce the stress concentration. What are those 7 methods? One is drilling additional holes. Second one is using fillets instead of shoulders, the sharp corners. Third one, use of multiple notches. Fourth one, using a larger diameter threaded knife. Fourth one, removal of unwanted material. Sixth one, combining grooves and fillets. And seventh one is using undercut shoulders. Now these are available in your data handbook, right? So please check the chapter number 4. Please go to the chapter number 4 in the design data handbook. These sketches also available. Clear? And below the sketch also, this is a sketch is taken from the data handbook only. These are all the sketches available in your data handbook. And also important question also is just refer your previous question paper. They will ask, explain the method of reducing the stress concentration on the mission element. Right, 68 marks. After this, before going to solve the problem, now what are the different type of components we'll consider? Here, first we'll consider a flat plate. Flat plate, see that the flat plate is a rectangular plate here, having width is W, length will not consider here. Again, if you view from the top view, the thickness is H or T. There is a flat plate, there is a machine element. Second one is a shaft, and third one is threaded fastener. These are the type of components that come subject to what are the different discontinuities are there. If we take a flat plate, what are the discontinuities? Geometrical discontinuities are, it may be a hole. So hole, see that a flat plate with a single hole, with the diameter of the hole is represented as D. Second one is a shoulder. See the flat plate with the shoulder, sudden decrease in dimension from capital D to small d. Third one is grooves or notches. See the grooves or notches, it may be V groove or circular groove, right? These are the different types of discontinuities. It may be a hole, shoulder, or notches. The type of component is here flat plate. Let's subject it to what type of load. The static load we consider here, there are three types of. Is I'm audible? PPT is also visible. Is anyone give me confirmation? Is anyone give me confirmation? Am I audible?
Yes, sir.
Okay. The first, we take the type of component. It may be a flat plate or a shaft or threaded fastener. That's the type of component having discontinuity. For the discontinuity, it may be a hole, it may be a shoulder, or it may be a groove or notches. Consider here flat plate. What type of notches? What type of discontinuity here? Here it is a hole. Here sudden decrease in dimension is a shoulder. Third one, if there may be a notch, there is a V notch or circular notches. Right? These are the different types of discontinuities. Geometrical discontinuity. Subject to what type of load? It may be axial load. See that the flat plate subject to a load. What type of load here? Axial load. Second one, bending movement. Bending movement. See the flat plate is subject to what type of load here? The bending movement. It tries to bend the component. Third one is twisting moment. The flat plate will not undergo any twisting here. The shaft will undergo twisting. See the shaft is subject to then what type of load here? Twisting moment. Tries to rotate the component. These are the different loads acting on the component. Right? First, always whenever you go for solve the problem, first identify the type of component. Second one, the type of discontinuity. And third one, the type of load acting on the component. These three things you should remember. Right? Similarly, go for a shaft. A shaft is subject to axial load. Right? The shaft is there subject to axial load. What type of discontinuity here? The shoulder. Right? Here, the shaft is subject to bending movement. The shaft is subject to twisting movement. Similarly, go for here one more the same component shaft. Here, the shaft is what type of discontinuity here? The groove. What type of groove is circular groove it is? Circular shaft. Right? Okay, subject to axial load, bending movement, and twisting movement. Clear? Right? Then one more very, very important, how to take the stress concentration factor, K suffix sigma. That data is obtained from the design data handbook. And also please take this screenshot of this. So for different types of components, subject to different type of load and discontinuity, we'll go for this different type of figure. For example, a flat plate with a hole subjected to a tension and bending moment. Then you go for refer the figure 4.5 and 4.6. Okay, now I'll move on to the design data handbook. So 1 minute. Yeah. Now see that chapter number 4. Now it is visible. Give me confirmation. On the screen, chapter 4, the design data handbook, stress concentration in machinery members. Is it visible? Is anyone please give me confirmation?
No, sir.
On the screen is not visible.
Visible, sir.
Is it visible? Yes. Now this chapter will use for stress concentration, the unit, right? So these are the notation symbols as you know that. See the So directly I'll move on to the figure number 4.5. Where is figure number 4.5? So in the continuity is not there, I think. Yeah, 4.5. See that in the figure 4.5 in a flat plate with the what type of discontinuity is a phone subject to axial load, right? How do you take the stress concentration factor? Look here. Now, as you know the diameter of the discontinuity, we know that phone we know that, and the width of the plate also we know that. Based on that, we'll go for take D by W ratio. That is the x-axis is D by W ratio. Y-axis is the stress concentration factor, right? For example, D by W is 0.2. D by W will get 0.2 for example. Then take the 0.2, draw a vertical line from the vertical line that touches the top, then draw horizontal line. Now the stress concentration factor is how much it is? 2.5. That you will get from the figure only. Clear? Now what is the formula for stress concentration factor? See that. Stress concentration factor, it is K sigma is equal to sigma nominal, sorry, maximum stress, sigma max divided by sigma nominal. What is the sigma nominal? Sigma nominal is equal to force by area. What is the area? Minimum area, cross-sectional area. W minus D into H. Where is H is nothing but what? The thickness of the flat plate. Clear? This is the way you have to take the stress concentration factor. When it comes to this solve the problem, so you know that how to take the value. How to take the value. Now the PPT is visible. Does anyone give me confirmation the PPT is visible? Does anyone give me confirmation? Yes, now the PPT is visible.
Yes, sir.
Yeah, now we will go for solve this problem. Please take this problem. Determine the maximum stress in the following cases, taking stress concentration into account. The first component is considered the rectangular plate of 50 mm into 80 mm. So 50 mm is the width, 80 mm is the length, with a hole of 10 mm diameter. In the center is loaded. The axial tension is how much? 10 kilonewton. And thickness of the plate is 10 mm. This is the first component is given. Second component is what? A circular shaft of 45 mm diameter. Step down 30 mm diameter. From 45 mm to 30 mm, you just step it down. Having a fillet radius of 6 mm. Subjected to a twisting moment of 150 Newton meter. Now we'll go for directly solve this problem. First, all of you listen carefully. Then if offline classes there, okay, in the tomorrow or day after tomorrow, we'll solve the problem also. Right? Now see that first, read the problem once or twice. Take the given data. What's the given data here? First, we go for determine maximum stresses in the following cases. What we are going to determine here? Maximum stresses. What is the stress here? Maximum stress induced in the component. First component is what? First identify type of component it is. The first one is the rectangular plate of 50 mm into 80 mm. 50 mm wide and 80 mm the length. And what type of discontinuity it is? It is a hole. It's given diameter of the discontinuity at the center of the rectangular plate is 10 mm. The rectangular plate is subject to what type of load here? Axial load, axial tensile load. And the thickness of the plate is 10 mm. This is the first component. Okay, first we'll consider first component. We'll solve the first component here. So see that our aim should calculate the maximum stress induced. Now we'll go according to draw the sketch here. This is a rectangular plate of width is how much? 50 mm, length is 80 mm, and thickness is H is how much? 10 mm, right? And is subject to what type of load here? The axial load. Subject to the axial load, right? Of how much? 10 kilonewton. Now what type of discontinuity here? Circular hole it is, right? Now how do you solve this problem? Whenever you read the problem once or twice, first take the given data. After the given data, check the unit conversion. Dimension should be in millimeter, force should be in Newton. Then immediately identify what type of component here, rectangular plate, what type of irregularity, it is a hole, what type of load is acting here, axial load. Then how do you calculate the maximum stress induced? As you know that, you know the stress concentration factor, the member is subject to axial load. For axial and bending load, what is the stress concentration factor? Formula is K suffix sigma is equal to maximum is the ratio of maximum stress to the nominal stress. Our aim is to determine is the maximum normal stress, right? If you want to determine maximum normal stress, I should know the what is the K suffix sigma and normal stress, sigma nominal stress, not normal, nominal stress. Then how to calculate K suffix sigma? Again, from the design data handbook, for plate with a hole subject to axial load, then you go for figure 4.5. In the figure 4.5, first you go for calculate what is the D by W ratio. What is the D by W ratio? D is almost 10 mm, W is 50 mm. From this you will get what is the D by W ratio is 0.20. Right? Now I'll move on to the data handbook. The top number 4. Now see the data handbook is visible. Give me confirmation. Data handbook is visible.
Yes, sir.
Yes. Now as you know that what is the D by W ratio is got from the problem. D is 10 mm, W is 50 mm. From this D by W we got 0.2, right? Once you get D by W is 0.2, see the from the figure 4.5. Now from the 0.2, draw vertical line that touches the curve and then draw the horizontal line. Now you get the K suffix sigma is equal to how much? K suffix sigma is equal to the stress concentration factor K suffix sigma is got how much? 2.5. 2.5. Is it right? Any doubt regarding this? How to take stress concentration factor from the data handbook?
No, sir.
Okay. Now after this, once you know the stress concentration factor, once you know the stress concentration factor is K suffix sigma is equal to how much? 2.5. Now substitute to that main equation. Substitute that value into the equation number 1. Before the substitute equation number 1, again, what is the nominal stress? Sorry. How to calculate nominal stress? Again, don't go for remember that formula. Nominal stress is multiple force by area. That in that figure itself is given. The nominal stress is put to F by W minus D into H. Is it right? The figure itself is given. In the data handbook itself, in that figure 4.5, below that itself is given the formula. So substitute the F value, W value, D value, and H value. You get nominal stress is how much? 25.25 Newton per mm square. Now substitute these two values, K suffix sigma and nominal stress, is the equation number 1. Now we'll get the maximum normal stress is, we get maximum normal stress is 62.5 Newton, 62.5 Newton per mm square. Again, the same for problem will solve when it comes to 6th semester in ANSYS. Plate with a whole problem in ANSYS software. This is a laboratory. Okay, in the 6th sem. Okay, now it's the same problem. Plate with a hole subject to axial load. The same problem we saw, same problem we consider. This is a theoretical method. There we go for solve by numerical method by using FEM software. Clear? Next, second component is what? Second one is a shaft, right? Here the shaft is subjected to, sorry. This is the first component. Next we go for second one is what? A shaft, right? A shaft is subjected, the shaft is decreased in diameter from 45 mm to 30 mm. What is the fillet radius is 6 mm and subjected to piston moment is 150 Newton meter is converted into Newton millimeter, right? please check the dimension. Then we go for solve the problem. Right? This is the what? The second one, the shaft diameter is 45 mm. The major dia step down into 30 mm diameter, and fillet rate is how much? 6 mm, and twisting moment is 150 Newton meter turned into Newton millimeter. The type of component is the shaft. The type of component shaft. Type of irregularity it is a shoulder, and type of load it is twisting moment. Again, as you know that what is stress concentration factor for when a component subjected to twisting movement, cast on load is a ratio of the maximum shear stress to the nominal shear stress. But then again, how do you calculate stress concentration factor? Again, from the design data handbook, a shaft with a shoulder subjected to twisting movement. Then refer the figure 4.19. In the figure 4.19, what is the ratio? D by D ratio should be know that. D by D ratio 45 by 30 you get 1.5, and R by D ratio also you should know that. R is 6 mm divided by 30, you get 0.2. These two values should remember. Right? And then the figure is 4.19. Now we'll move on to that. The data handbook. So what is the figure number? 4.19. Figure 4.19. Now the shaft is separated to what type of load here? Twisting movement. Is a step down from capital D to small d, right? So this figure you will go for using. Right? So in this figure, you can see that what is the capital D by D? 45 by 30. How much you got? It's capital D by small d. Does anyone remember the value, or tell me that what is the value you got? 45 by 30. You will get 1.5. Now you see the 1.5 line. Where is 1.5? This is a curve. Is the curve where is from? Capital D by D 1.09, right? 1.33, 1.20, then 2. But which one I want to refer? 1.50 is nearer to 1.33, right? Next, R by D ratio. R is 6 mm divided by 30. That we get 0.2. This is the x-axis is R by D ratio. That is a 0.2. Right? So after this, so from the R by D ratio, 0.2, draw a vertical line. Now which line you have to consider here? 1.33. Right? This is 1.5 near to 1.33. Then you draw a vertical line from this. Now from 1 to 1.4, you will get that value. Again, with the help of scale. Okay, you go for use it. So approximately is a one. How many scales are there? How many divisions are there from 1 to 1.4? With the help of the steel tool or scale, you measure it. Then take that value. It approximately is 1.3 or 1.25. Okay, 1.2 or 1.25 will get. Yes, 1.25. The stress concentration factor is 1.25 will get. Then how do you calculate nominal stress? Again, in that the data handbook, you can see that how to get nominal stress. The nominal shear stress is given. What the nominal shear stress is? MT by J into C. MT we already know that is given how much? 150 Newton millimeter turned into Newton millimeter. 150 into 10 raised to power of 3 Newton millimeter. J is what? Here itself is given. J value is pi d to the power of 4 by 32. Right? Pi d to the power of 4 by 32. Small d, which is small d here? That is 30 mm. So 30 mm. Pi d to the power of 4 by 32. Now what is C? C stands for what? Distance from the center of axis to the outer fiber. That also that formula is given. C is equal to what? T by 2. Let's substitute all those values and calculate a nominal shear stress. Nominal shear stress. How much you got nominal shear stress here? You get 28.29. 28.29 Newton per mm square. Then substitute this nominal shear stress in the equation 2 and stress intensity factor, sorry, stress concentration factor, K suffix tau. Then you go for calculate the maximum shear stress. Then you go for calculate the maximum shear stress. Sorry, what is the maximum shear stress you got? That is 35.36 Newton per mm square. This is a way how to calculate the maximum normal stresses and maximum shear stresses. Now read the problem once or twice, then identify type of issue element, then type of discontinuity and type of load acting on the component. Based on that, we go for use the figure and take the stress concentration factor. Here, try to solve one or two problems. Okay, similarly, the next problem like this. Here are two discontinuities are there. Indicate as location AA and location BB. Let's try to solve this problem. Okay, take the screenshot of this. Of location A and location B. Here, flat plate here with a hole and also with a notch. Flat plate with a hole, the same procedure what we followed in the previous step. Second one is a notch. Only the diagram will change here. That's the stress concentration. The data you should take from the design data handbook. Then calculate what is the maximum stresses induced. Okay, similarly, we go for try in the next class some other problems. Okay, up to this we'll stop here. So today we'll discuss two major topics. One is failure theories. As you know that what are failure theories? Failure theories are the prediction of the failure of a component when the component will fail. There is a prediction of failure of component when you subject it to an external load. That is what is a failure theory, right? How do you predict? With the help of some failure theories, such as total 7 failure theories are there. What are those? How do you remember that? 3 failure theories are related to stress, 1 failure theory related to strain, and other two failure theories are related to the energy theories, right? That's why you have to remember the failure theories. Next, after that, what we discuss? Stress concentration. Now, what do you mean by stress concentration? The accumulation or localization of the maximum stresses induced in the component. When the maximum stress induced in the component, there is an irregularities are due to a abrupt change in geometry. There you go for the maximum stresses are accumulated in the component. That is what is the stress concentration. Now, how do you get the stress concentration? What are the discontinuities are there? It may be geometrical discontinuity, it may be material discontinuity, or it may be a loading discontinuity, right? Then after that, we discuss about what is the stress concentration factor. Stress concentration factor is the ratio of the maximum stress to the nominal stress. Is the ratio of maximum stress to the nominal stress. Then we discuss actual. Those are for as the theoretical stress concentration factor means by using theoretical formulas, we'll go for calculate it. Then we'll go for use actual stress concentration factor that depend upon the material and the load, type of load, right? Then we'll solve some problems on the how to calculate maximum stresses induced in the component. It may be flat plate or a circular shaft or a threaded fashion. Again, for your syllabus, only a flat plate and circular shaft is there. There is no threaded, the threaded length. That type of stress, the geometry derivatives will not discuss. Okay. Yes. Any doubt regarding this today's session? If you have doubt, please unmute yourself. So I'll try to upload the session also in the YouTube and also send the link to the respective group. Those who are absent or those who are not understood, please go through it. Or else in offline class tomorrow or day after tomorrow, we'll go for just a brief introduction about these two topics, and we'll also solve some problems on the topic. Right? Any doubt?
No, sir.
No doubt. Okay, total 54, 55 participants are there. Out of 96 members, 96, 97 members. Right? Okay. So we'll go for a brief introduction or summarize these two topics in offline class. Okay, thank you one and all for attending this meeting. Thank you one and all. So we'll end this meeting. Any other doubts? No
No,
doubts,
sir.
end this meeting. Okay. Yes, thank you one and all for attending this meeting. I'm ending this meeting now.